my pre-algebraers. This is another guys, our last really instructional lesson that we're going to have for all of pre-algebra. That's pretty cool too, isn't it? We are making some headway, guys. We will still have one more video for math, and that's going to be the review for our test, and that'll be tomorrow on Tuesday. And then I'm going to give you all of Wednesday and all of Thursday to take your tests. So we only have this one period left of new teaching, so let's get right to it, and then we're done. No new teaching other than really what isn't new, and that's just going to be our review tomorrow. Trip over toy, you know how that works in this room. Okay, so what we're going to be discussing today is the volumes of pyramids, cones, and spheres. Now, if you recall, we've already dealt with the area of pyramids, cones, and as well as spheres. And I don't have a picture up here, but remember, that's just a three-dimensional circle. It's like a ball, like a basketball. That's a sphere. Earth is a sphere, a three-dimensional circle or circular anyway shape. So we've done areas of these three. What we haven't done is volumes, and those formulas are going to be just a little bit different than what the formulas for finding the area of a pyramid, a cone, or what a sphere is. Okay, we're going to have two important formulas that, as always, you need to write down. As you can tell, those are in different colors, top left and top right respectively, of my little tiny little boy and little girl board. Alright, so our first formula is going to be the volume, and I don't have this written, so make sure that you do write this down. The first one is a formula for pyramids and for cones as far as volume. The volume formula for pyramids and for cones, that's top left, not top right, but top left. Volumes of pyramids and cones, you use exactly the same formula for them. And what that is, guys, the volume equals one-third times the area, and listen to me closely, the area, not the volume, but the area of the base. So listen, to find the volume, you have to use area of the base. And that can be a little confusing. I don't think it's terrible, but it could be a little bit. So do be aware of that. So volume of a pyramid, or volume of a pyramid or of a cone is one-third times the area of that shape's base. In the case of a pyramid, that's going to be a square at the bottom. That's the base. In the case of a cone, that's going to be a circle at the bottom, times the height. All right, just times the upward dimension, the height of that shape. And so let's start out. Number one, I really don't think this will take us too long. These are pretty simple, just 4 problems to do. What is the volume of this pyramid? Well, the first thing that I'm going to do, guys, is write my formula. V equals one-third, and since I have it written up here, base times height, and my space is limited, I'm not going to write all that formula out. However, in your nearly unlimited space on your papers, I would encourage you to write the whole formula out each time so that you do get more familiar with it. So one-third of the base. The base of this pyramid, guys, is the shape of a square. And remember, base in a volume formula is determined by the area of the base of that shape. And that shape is a square at the base. And who can tell me, even though I can't hear you, act like I can. Who can tell me, who can say out loud, or at least kind of under your breath, who can tell me what the area for a square is? How do you find the area of a square? Guys, area of a square, since all 4 sides are exactly the same, just choose one of the sides, doesn't matter which one, and you square that side number. And that's going to give you the area of a square. And look, since they're all 4 the same, this one's 8, that one's 8, implied, that one's 8, that one's 8. I can choose any one because they're all the same number, 8. So V equals one-third times the area of the base, okay, which is one of the sides squared. And so it's going to be 8. Don't forget your square. All right, it's the area of the base, not just one side of the base, But in the case of a square, one side squared. So V equals 1/3 times 8 squared, and then guys, what is the height of this shape? From the floor all the way to the top of that pyramid is 12 centimeters. So it's going to be times 12. Okay, let's simplify. Remember, even though it may not be found first, we simplify exponents before we do multiplication. So let's keep our 1/3. What is 8 squared, or 8 times 8? Not 8 times 2, but 8 times 8 is what? Good job. 64. And then times 12. And now what I'm going to do is come right over there with you folks. You fine folks, by the way. Good pre-algebras. And what I'm going to punch in is the fraction 1/3. And I haven't been using this on here, but can you see right under that second, there's a little square box and then a divisive line and then a little square box. That's actually a fraction format. And so what I can do is put in 1 on top. Here, hit this right arrow button. Did you see that? There it is. I think it was out of the screen, that right arrow button. And then I can put in 3. And so look, isn't that cool? I have 1/3. And I'm sure you probably have something similar on your calculator, and you may have the same app that I do if you're using an Apple product. But if not, you probably have something similar you can use. So 1/3, oh, no, I'm done with that, aren't I? 1/3, and if I hit over, I think, yep, if I hit over, I'm good now. So I hit that over button again, now I'm off the fractions. So 1/3 times 64 times 12. And see, my calculator will do it all at once, and I'm sure yours will too. And so my answer, guys, is 256. So the volume of that pyramid is 256 units, cm, centimeters, and in everything I measure volume, it's units cubed. Now if I'm doing units in area, it's always what? Squared. But if I'm doing units in volume, it's always cubed. Okay, so that's pretty easy, isn't it? Not too bad. Let's do the volume of this cone. Find the volume of this cone. Remember, the formula for finding the volume of a pyramid and a cone is exactly the same thing. And so I'm just going to rewrite my formula. V equals, and this time I think I will write it, I didn't here, but 1/3 times the area, remember, of the base is what B means. The area of the base of that shape times H. Okay? Now, how am I going to do that? What is the area of this base, the shape of which is a circle? Does anybody recall what the formula for the area of a circle, what it is? The area of a circle formula is A equals pi times r squared. So that's the area of a circle. And therefore for B, I'm going to plug in pi times whatever the radius is of that circle, which is halfway across that circle, and square whatever that radius is, and then multiply it by my height. So what I have is V equals 1/3. Okay, and then I'm going to say times pi, because that's my formula for the area of the circle, and I'm trying to find for my base what the area of that circle is. What's my radius, though, to do so? Halfway across the circle. Right there. That's 4 centimeters. So I'm going to put times 4 squared. Remember, that's really important. And then times what my height is. So what is my height? From the floor all the way to the top of that cone is 6 centimeters. Okay, first things first, before I punch into my calculator, although probably all of our calculators will do this too, but it helps to do some mental work. 1/3 times pi, we know what that is, 3.14, times, what's 4 squared? Not 4 times 2, but 4 times 4 is 16. And then keep your height times 6. And so I'm going to come right back over, guys, to where you are. And I'm going to pull back up after get my screenshot of my kids off there. Love them, but I love math too. What we're going to do is we're going to punch in from my fraction. Let me back up just a little bit so you can see a little bit better. 1, and then over. Remember that over button for me, maybe different for you. 3, and then I'm going to hit over again to get off the fraction now. So 1/3 times pi, which is 3.14, times 16, which is the radius squared, times 6, which is the height. And that is 100.48. And let's keep rounding to the nearest tenth. All right, so it's 100.48. Because that's an 8, I'm going to go up in the 10th spot. So V equals 100.5 is my volume. Units, centimeters, squared or cubed? Measuring in volume, so cubed. Units cubed, and not units squared. Alright, good job on that one, guys. We're already halfway done. This isn't hard, is it? I think this is easier and maybe even a little more fun than the stuff that we were doing before. Allow me to read to you, please. Problem number 3. Find the volume of a sphere, okay, a three-dimensional ball, basically, with a diameter of 15 feet, and find that to the nearest hundredth, the volume of the sphere. And then when you calculate that, find the number of gallons it will hold. And we're given this handy-dandy conversion technique, which is 1 foot cubed, about said it wrong, didn't I? 1 foot cubed is equivalent to 7.48 gallons. And that's how whenever we get our feet squared in the, or feet, there, we did it again. Whenever we get our feet cubed in the end, we will convert it over into gallons using this conversion rate right here. We'll worry about that in the end. Before we do numbers 3 and 4, both of which will deal with spheres, I need to give you this important spheric formula. And that is volume of a sphere equals, instead of the fraction 1/3, this is a weird one, isn't it? 4/3. 4/3, or 1 1/3, or 1.3 repeating, if you like decimals or mixed numbers. So volume equals 4/3 as an improper fraction times pi times the radius cubed instead of squared. And that's the difference. So I'm going to write this because it's different. We don't have any shapes to interrupt here. We have a little more space. V equals, our formula is V equals 4/3 times pi times r, or the radius, halfway across that circle, cubed. Okay, let's go ahead and plug in some important information here. We're trying to find volume, so that variable remains. V equals the constant, 4/3, times another constant, pi. Now guys, do I have a radius that I'm given in this information? Yes and no. No, in that I don't see radius and a number that's connected to it, but yes, in that I see that this three-dimensional circle has a diameter of 15 feet. Guys, what's the difference? Do you remember what's the difference between diameter and radius? Radius is not diameter, and diameter is not radius. The diameter is the full length. Here, let me show you, and then I'll erase it. But diameter is the full length all the way across the circle. But all I want is what's halfway across the circle. And if I'm given what's found all the way across the circle, 15, and I'm a little up, but if that were perfectly in the middle, and this is a little down, but if they're perfectly in the middle and all the way across is 15 feet, guys, what's the radius, or halfway across? All I have to do is divide the diameter, that number 15 in this case, by the number 2. Cut it in half, and then you have halfway across. And so the radius is going to be, what's half of 15? Well, half of 14 is 7, and then half again, because half of 14 is 7, and half of 16, the number above, the numbers below and above, 7 and 8, but what's midway, or half of 15? Halfway between 7 and 8 is 0.5. And so that's going to be my radius. If my diameter is 15 across, all the way across the circle, then my radius has to be 7.5 feet. And so now that I know that, I'm going to erase, well, I may be able to keep it. We'll see if I need that. I don't know that I will. Okay, so my radius is going to be what? 7.5, which we found by cutting the diameter in half. So 7.5, and that is going to be cubed. Okay, so we're going to have 4/3 times pi times, I'm just going to punch in my calculator instead of walking all the way up there. I'm going to punch into my calculator 7.5 right now, and I'm going to put that to the 3rd power. Or if it's easier for you guys, just do 7.5 times 7.5 times 7.5. And you can do it that way in your calculator also. Alright, and the number that I get there, simplifying that exponent before I multiply, is 421.875. I'm using more decimals right now because I don't have my final answer, but when it's all said and done, I just want to the nearest tenth. Okay, so now I'm going to come over where you are, and I have that 421, I have that right on the board, yeah, 0.875. I'm going to take that answer and multiply it by pi, which is 3.14, and multiply those two by the fraction. We'll see back on this page. Here we go, front page. On the fraction, by the fraction, 4, and then I'll go over and thirds. Okay? And all that multiplied together is going to give me 1766.25. Now I want it to the 10th, so is it going to stay at a 2 or is it going to go up to a 3? Because my 100 spot's a 5, it's going to go up to the 3, isn't it? So 1766.3. Let's see if I can get off all these toys here. Volume equals 17, as you saw, 66.3 in what units? Feet. And because it's volume, feet squared or feet cubed? There you go, you're getting it. Feet cubed, because I just measured volume. Now I do want to erase this right here, and here's why. Remember, this problem has 2 legs to it, just like you and I have. This is not a peg leg problem. This is a 2-legged problem, just like human beings. The second part of the question, also find the gallons that are the cubic capacity, is what that's called, of this sphere. Like maybe a water tower. It's got a big ball on top that holds water. How can I find, if I know the cubic feet of it, how can I find the gallons? This conversion technique. 1 foot cubed is equivalent to 7.48 gallons. And so what I can do is take 1766.3 feet cubed, okay? 1766.3 feet cubed, and multiply that by 7.48 gallons. And whenever I do that, let's do that together. Whenever I do that, shouldn't have cleared it out, huh? To punch all that big long number back in. 17.6, oh, don't do that to me. Don't do that to me, stop it. Okay, so here we go, ready? When I punch in 1766.3 times 7.48, yo, Homer G, look at what I get. 1320, and the question is find the gallons, and on this one let's just round it to the nearest gallon, okay? So how do we do that? From that 0.9, do we stay at the whole number 1 that's before it, or do we go up to a 2? Well, since it's a 9, we go up to a 2. So our final number is going to be 13,212 if we're doing to the nearest gallon, and we'll do it on this one, okay? How about 13,212 gallons? All right, now where this one is unique is that we're not going to do gallons cubed, but just simply gallons. That's where we'll end on that one. Now, if it's space, you know, the space itself, like the feet, that would be different, but the gallons, we just leave it at that. And by the way, when you go to the store and you buy a gallon of milk, you don't buy a cubic gallon, do you? You just buy a gallon. So does that make more sense as to why we leave it in that? All right, how about number 4? What is the radius of a sphere with a volume of 288 times pi meters cubed? This one's one of those different ones, and we did something like this with area, but now we're going to do it with volume, where we're given the volume, and we have to work backward to find the radius. And so the first thing we need to do is not say, oh, it's too hard to give up, because we're not going to succeed at life when we do that, and we might not pass math if we have that attitude. Not only can we do it and pass math, but we can also do things like this and vibrantly succeed in life. First thing I do is just rewrite my formula. V equals 4 over 3 times pi times r cubed. All right, and now guys, we're just going to plug in the information that we have. What's the volume of this sphere? 288 times pi. And since that is the volume, V, we put that figure in for V. 288 times pi. Don't forget about that. That's really important. Equals 4/3 times pi. Do we know the radius? No. That's what we're trying to find. Okay? And since that's what we're trying to find, we leave r, but don't forget to leave the cubed exponent that's attached to it. Okay, so what's step 1 in this process? Well, guys, what I'm going to have to do is get r to the 3rd power all by itself if I'm ever going to solve for r. And since all this is multiplied together, and I need to detach the 4/3, and I need to detach the pi, and they're all being multiplied to r to the 3rd, what do I do to get rid of them? What's the opposite operation for the 4/3 and the pi? I divide both sides by 4/3 and by pi. Now, the reason that works out really well, obviously that gets rid of those on the right side, which is what I want to isolate r cubed. But look, I've kept it in pi form, and that's really handy because I have a pi being multiplied on top and I have a pi being multiplied on bottom. And if I divide pi by pi, what happens to my 2 pi's? I had one for a total of 2, but since they're dividing each other, they're gone. They just turn into invisible ones. And so all that I have left, and remember, I can switch that if I want to the left side and put that on the other side, and it's the same difference whether I read it that way or this way. Because 288 divided by 4/3 equals r to the 3rd power is, look, from this direction, r to the 3rd power equals 288 over 4/3. So you can read it either way, and it's correct. So r to the 3rd power equals, okay, what I'm going to do is come over where you are, and I'm going to punch into my handy-dandy man-made calculator to help my handy-dandy God-made calculator to understand this one and to process just a little faster, even though we could do it the hard, old-fashioned way. What I'm going to do is put in 288, guys, divided by 4/3, and here's where I'm going to use that fraction feature in my calculator. Find the equivalent on yours, and you can use it too. 288 divided by 4/3 is 216. So what I have is r cubed equals 216. Question: am I trying to find the radius cubed? No. I've been asked to find the radius period. And so how do I get rid, guys, before I show you this, how do I get rid of an r cubed? I have to do the opposite or the inverse operation. What is the opposite? Do you remember this from our radicals chapter, the last one, number 11? What is the opposite of cubing something? It is taking the cubed root. And so I'm going to take the cubed root, guys, from both sides. And the purpose of doing that on the left side is opposite operations. They cancel each other out and it just leaves me with r. If I have r cubed and I take the cubed root of r cubed, my cube is done away with. I have no cubic root, I have no cube. They're gone. However, to simplify, I also have to take the, yeah, I have it, don't I? Cube root. I thought maybe I had the square root, but no, got it right for once. I'm going to take the, here, let me back up so you can see a little bit better. Alright, I'm going to take the cubed root and see that feature, that button on mine. That's not what I was after. Let's try this again. You still with me? Okay, it's the cubed root, not the cube, right? There we go, looks a little better. I'm going to take the cubed root of 216. In other words, what times itself equals 216? Well, that's the number 6. And therefore, the cubed root of 216 is the number 6. And in what units am I measuring? Well, the volume is in meters cubed. Therefore, we know that the radius of that sphere has to be 6 meters. Not meters cubed, not meters squared. Remember, the basic components just start out with the unit itself. But if you're finding the volume, which we're not, we used volume, but we weren't finding it. If you are finding the volume, it's going to be units cubed. If you're finding one of the pieces of the puzzle, like the radius, it's simply going to be in units, not cubed and not squared. And guys, that is the volume, finding the volume of either a pyramid, a cone, or a grandiose I should say, sphere. Guys, we are done with new instructional material for pre-algebra. But we're not done with pre-algebra. Your final homework assignment is assigned. That is quiz number 4. And now you do have until Wednesday to turn that in. However, remember, it is to your advantage to get it done pronto, like today, and turn it in to me. Let me grade it, look it over and make your corrections. A, for a better grade. B, because you also get to use your quizzes in addition to your notes on your test. And if you have correct answers on your quizzes, that helps you get more correct answers on your test too. All right, guys, that's all. I will see you tomorrow when we are going to do a review for that final test that we're going to be taking in pre-algebra.